Hello students. So coming to the unit 1, that is sequences. So I am going to define the definition of sequence. So sequence definition. So if A is a non-empty set, if capital A is a non-empty set, non-empty subset, then a function S mapping from N to A is called a sequence, and it is denoted by sequence Sn or simply sequence Sn. So sequence can be denoted in this way, right? So coming to the definition of sequence, a sequence is nothing but a function from set of all natural numbers to the non-empty subset of natural numbers. If you say that S is a function from N to A, so then we say that S is a sequence. Okay, we can define in this way. Or so a sequence can also be defined in another way for understanding. That is, a sequence is a list of numbers placed in a definite order. Means, for example, I am writing sequence Sn is equal to 1, 2, 3, 4, and so on. So what I am saying is a sequence is nothing but that is a list of numbers placed in a definite order. Here the numbers are the set of all natural numbers. Okay, so arrangement a list of numbers with some rule. Okay, suppose if you write 2, 4, 6, 8, 10, 12 and so on as a sequence, so then we call that is a set of all even numbers. Similarly, if you write 1, 3, 5, 7 and so on, we call that as a sequence of odd numbers. So sequence is nothing but it is a list of numbers placed in a definite order. Okay, so definitely there will be some rule involved in that sequence. So finally, a sequence is a list of numbers placed in a definite order, right? So we are having 3 ways of representing a sequence. We can represent sequence in 3 ways. Okay, so next point, that is what I'm going to discuss. So methods of representing a sequence. So coming to the first one, so a sequence can be represented in several ways. Okay, so coming to the first one. So one way of representing a sequence is by writing the first few elements of a sequence. Okay, this is one way of representing a sequence. It means, for example, I am writing sequence Sn as 1, 4, 9, 16, and so on. So in this sequence, I have just written the first few elements. So this is one way of representing a sequence. Okay. So here also we say that this is a sequence of list of numbers with some definite order. And that order is nothing but here the sum of the squares of the natural numbers. The numbers in the sequence are the squares of the natural numbers. 1 square, 2 square, 3 square, 4 square, 5 square, and so on. So those numbers are in this sequence. Okay. So this is one way of representing a sequence. And coming to the second one. Second way of representing a sequence is by writing its nth term. By writing its nth term. For example, sequence Sn is equal to sequence of n square such that n belongs to n. So here I have just written only the nth term. So where n belongs to n. So here n is nothing but set of all natural numbers. If we select 1 from capital N, we get 1. And 2 from capital N, we get 4. Next 9. Next 16, 25, and so on. Okay. So in the first example, I mean, in the first definition, in the first representation, so we have written the first few elements of the sequence. Whereas in the second representation, we have written the nth term of the sequence. So a sequence can be represented in any way. Okay. So this is the second one. Coming to the third one. So the third way of representing a sequence is by writing a recursion formula. By writing a recursion formula. So that is, for understanding, example, S1 is equal to 1, comma, Sn plus 1 is equal to 2 into Sn. This is true for all n belongs to n. And n is greater than or equal to 1. Right. So here, so the third way of representing a sequence is nothing but recursion formula. So what is recursion formula means? Here we have given S1 is equal to 1 and Sn plus 1 is equal to 2 into Sn. So if you want to write S2, since S1 was given, if you want to write S2, we have to substitute n is equal to 1 in Sn plus 1. So that we get S2 is equal to 2 into S1. Okay. So here S1 is 1. So that we have to substitute the value of S1 in S2. So that we get S2. And after, if you want to find S3, so then we get S3 is equal to S2. Once again, we have to substitute the value of S2 in S3 to get the value of S3. It means with the help of its previous term only, we are able to define that next term. Okay. If you want to write S2, we want S1. If you want to write S3, we want S2. It means with the help of its previous term, we are going to define the next term. So in this way of representing a sequence is nothing but recursion formula. So this is recursion formula. Okay. So a sequence may be represented in any of these three ways. Okay. So the third one is the most important one. In generally, we will see the first and second forms very number of times while doing problems in sequences. Okay. So the one way is just writing its first few terms in the sequence. That is one way of representation. And the second way is, so just by writing its nth term. So just by writing its nth term is one way of representation. And coming to the third one, that is by representing its recursion formula. Okay. So these are the ways of representing a sequence we are having in our sequences. Okay. Right. So coming to the next definition, that is a range of a sequence. The next point, that is range of a sequence. The set of all terms of a sequence is called the range of the sequence. It's called the range of the sequence. So whatever the elements we are having in the sequence, so the set of all those elements in the sequence is called the range of the sequence. That is the definition of range. So for example, I am writing if Sn is equal to set of 1 by n such that n belongs to n. So then the range of sequence Sn is equal to 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So the set of all the elements of the sequence is called the range of the sequence. Okay. So which is, of course, this is an infinite set. Which is an infinite set. Okay. So range is nothing but the set of all the elements of the sequence is called the range of the sequence. That is the definition of range. So coming to the next definition, that is constant sequence. What do you mean by a constant sequence? So a constant sequence is nothing but if all the elements in the sequence are same, so then we call that sequence as a constant sequence. Okay. So coming to the definition, a sequence Sn is said to be constant sequence if Sn is equal to k for all n belongs to n. It means S1 is k, S2 is k, S3 is k, S4 is k, all the elements. S1 is nothing but the first element in the sequence. S2 is the second element of the sequence. S3 is third element of the sequence. So if all the elements in the sequence are same, okay, then we call that sequence as a constant sequence. So that is the definition of constant sequence for all k. Of course, for all n belongs to n comma, k is a fixed number. K is a fixed number. Is called a constant sequence. Right. Okay, right.